short-term training program. Uh, so basically, what we do, we at Sudaksh, our core domain is to work on the core technology of the drones, where we deal with flight controllers and communication systems of a drone. And as a part of it, we are also into providing a service of surveying and mapping for the agriculture and mining purposes. So before we start this session and before we understand the application of drones, first thing which is very necessary to clear is exactly what is drone. So whenever we talk to someone that we will deal with drones, the first thing comes into everyone's mind is that that four-blade thing which usually they see in the marriage. So definitely that is a drone, but the drone definitely is not only limited to multi-rotors or quadcopter or hexacopters only. Anything which can fly, that can be covered in drone. Okay. So this all types. So basically, we don't call a drone. We use the word UAV, unmanned aerial vehicle. So anything which can stay airborne without any kind of human intervention, we call it drones or UAV, unmanned aerial system. If we remove the A, means aerial, then it becomes a UV, unmanned vehicles, and that is also a very huge domain, currently growing domain in the world. So majorly this aerial vehicles are divided in two parts: lighter than air and heavier than air. So lighter than air is a commonly known as a helium balloon, which we usually see as either a fire balloon or a helium balloon. That can be considered as a lighter than air UAVs, and currently different companies like Google, Facebook, and Elon Musk, they are trying to use this light than air technology to provide a very efficient uh, surveying system in the space, and they are planning to provide internet even using this lighter than air drone system. And second category comes is a heavier than air, which normally we usually see around us. So first one is a non-powered drone, which is a glider. Basically, glider have a low velocity flight character. It requires a minimum power or almost no power to fly. So usually we usually take it from some specific height and then just drop it, so it can fly for longer hours in the air with a minimum power supply. Another thing is a power driven. So power driven are mainly divided into three parts: aeroplane, we call it fixed wing, rotorcraft, and ornithopter. So in aeroplane, the wing is fixed, where a vehicle needs to be in motion. A vehicle needs to travel so that it can generate a lift. Then another thing comes where we are rotating a wing and uh, keeping a vehicle stationary. That becomes a rotorcraft. Now, on the screen which you are seeing is a helicopter which has a single blade. But with increasing number of blades, we call it on those numbers. So, say for example, if it is a two blade, two fans, two propellers, then we call it bicopter. If that count goes to four, we call it quadcopter. If that count goes to six, we call it hexacopter, and so on, octacopter, and in the multiplication of that. So whatever currently usually we are seeing in the market with the multiple blades are called falls under rotorcraft, as a multicopter, and based upon your requirement, we use quadcopter or hexacopter or bicopter, depends upon our requirement. And third category, ornithopter. So the most common example of ornithopter is that Uri bird which they show in the movie. So aircraft which flies like a bird, where wing is in the flapping motion. So that category is called ornithopter. And ornithopter is not that easy to achieve in the terms of drones. It has a very high complex mechanical requirement, but currently it has a very huge research market in the world where people are more and more trying to make drones looks like a bird to make it stealth. So if you take any fixed wing or autograph, people are going to identify, okay, yeah, it's something a kind of vehicle. But if you go to ornithopter and make it more realistic like a bird, so it's little bit difficult to find it. So in the terms of surveillance and spying, ornithopter is going to find a huge requirement. So in the fundamentals, so how this fixed wing fly? So to balance our four forces, we make it fly, we need to balance four forces. Uh, First, we need the gravity force, which is weight. So to compensate, we need a lift, and to make it move forward, you need to overcome a drag. So these are the basic four fundamentals how things fly. Now, so to generate a lift and the fixed wing type, we need to keep aircraft in motion. If it stops, lift will get stopped and it will crash. So if you use a fixed wing, you can't hover it on a one single place. You need to be in constant motion if you are using a fixed. On the other side, if you go for a multi-rotor thing, so multi-rotor have a rotating blade. So here you also need to balance the four forces, your thrust, weight, lift, drag, and everything. But here, instead of keeping your vehicle in the constant motion, if you want to make it static, you can use your thrust to stay in a motion. So if your requirement is something where you need to be static at some specific point, or your requirement is to keep moving and hold your vehicle, then the multi-rotor is the best option. But a problem with is, so let's compare these two things. So in the fixed wing, your lift force means the force which keeps you in the air is generated by wing. So here, what power you need to give is only a drag force. So you need to provide a drag force. So comparative power requirement in this is less. On other side, if you go for a multi-rotor, then it requires a lot more power than a fixed wing, almost 4 to 5 times, because the force which keeps you in the air needs to be powered by you. So thrust means lift force should be generated by you. So you require a high power capacity for that, and which limits the flight time of a drone. Second thing, as your core thrust force is in the vertical line, so to make it in a forward motion, you need to incline your drone, and your thrust vector will provide you a forward force. So velocity is also a constant in the multi-rotor. In terms of fixed wing, you can achieve a very high velocity, but in multi-rotor, it's difficult to achieve that. If you want to achieve that, you need a more power, and proportionally, it increases everything in a lot more manner. So this was just a basic introduction about things, that what are the basic technology behind it, so that when whatever we plan in the future, we can show it. Now, another thing which I want to show you in the basic introduction is a controlling software. Yeah. Okay. So, why we need to use drone? Because in the terms of GIS, we already have a lot of sufficient data for in the satellite imagery system. So why do we need to use drone? Why we need additional systems to make it possible? So for that, let's take one example. So, say for example, if you are planning to uh, use Google Map for your reference, a satellite imagery, which is an open source, and if you want it in little bit higher resolution, then you can also get it on a paid basis. So, but why can't we directly use it? So basically, if we observe any satellite image, specifically in the Google Map, so we will always find in the satellite image, not in the orthographic map, but in satellite images, we will always find relief displacement. So what is this relief displacement? Yeah. So here you can see that this is a satellite image of uh, your Dubai area. But if you will see this Burj Khalifa, if we call it a map, then it should be in a on a top view thing. But satellites may not always available on the top of those things. So this inclined thing is called relief displacement. So so to observe anything, this creates some kind of error. Using this relief displacement, you can definitely count the height of the thing. So it's based upon your data, but in this thing you can find those errors. Uh, Secondary, satellite imaginary resolution is definitely going to always an issue. You can't uh, use it for a ultra high resolution. Though if you go for a purchase of paid data, still your resolution will be 1 meter by 1 meter. But in the case of drones, uh, it won't be like that. You can get more detailed resolution and you can set your parameters as per that. And third thing is a timing. So say for example, your certain application requires uh, real-time data. So if you want a data of specifically, say for example, tomorrow, 23rd September, but there may be a chance that at that time a satellite might not be available there or may not, it won't be there at your desired time. So in the terms of drones, it won't also happen here. Here you can set your schedule. Here you can set your requirements according. And fourth thing is of operation. So say for example that I want to survey. This is a Svalbard sanctuary of nearby Ahmedabad. So if I want to okay, so if I want to make a survey of this region, and I don't have a skill where I can flight on myself. So what should I do? And this is the reason why this whole thing is currently constantly booming. You just need to plan a flight. You just need to set a takeoff point. You just need to set a path. On during that path, you can give all kind of parameters, and after that, just boom, you are ready to go. I guess software have some kind of technical issue. So I was planning to. Okay, okay, I can start about. Okay, I don't. The software have some. It's technical glitch. No issue. So uh, this this way I want to try to explain you that why drone is currently constantly finding its more and more applications, and how many versatile things is possible using drone. Okay, so say for example I want to uh, uh, make a peripheral survey of this region. So I just need to mark my path in which region I want to do a survey. And that's it. And now I just need to see a point that what can I do. So here I will just use a takeoff to altitude at what level? 100 feet. Then these are the waypoints. During the waypoint, I I can give various kind of commands. If I want to make a turn here, or landing, or return to launch, or if I need to set some kind of specific hold, if I need to change the speed, if I need to drop something using parachute, if I want to capture a photo or anything, uh, I can set here. Otherwise, I can just simply leave it to waypoint. So it will just reach there and will follow that path. And at the last point, I just need to set land, and that's it. So, and once I will load this file to the flight, my drone, and will make it fly, it will just simply fly on this path and will come back. Nothing more I need to do. This is this simple operation uh, which usually we use. And that's why, due to this level of convenience, even you don't need to learn flying. You just need to know how to choose a waypoint, how to do it. Okay. Hmm. So now coming to the remote sensing part. So first thing we talk about drone, a basic thing about drone, what are the drones and what are the things which you can do using drone. So hope that basic concept is clear to you about drone. Okay. Hmm. Now, so this remote sensing. So is this remote sensing thing something new? Is this yet something new which came into existence and become very popular after this drone? Yeah, became popular with after drone, but it is a very old concept, and it started in 1858, where French balloonist Gaspard Felix Turgeon took a first image from the sky. So he was a balloonist. So using that fire balloon, he went to the sky and took the first image of the Earth from sky. Then in 1882, British meteorologist E.D. Archibald did aerial photography using kite and introduced the unmanned activities. See, so this unmanned vehicle system is not something new. It's way back started in 1882 where they were using kite. And using. But major everything accelerated during World War One and Two, where they find a very different applications of mapping and surveying and spying using this kind of systems, and which provided them a lot of funds for research, and eventually it is where we are today. Drone is available to each and every person of this human being. Everyone can use it. Everyone can get aerial image. We have, even if we don't want to go for a drone, we have a lot of open database available for remote sensing maps and everything. Uh, so now among all this, where we can use drones in the GIS. So first thing we can do is a mapping of land. So mapping of land should it be limited to some kind like Google Map? Uh, yes, so definitely it is something moreover like a Google Map, but it will create a map on a real-time basis as per your requirement. So say for example, first example is a landslide affected area. So due to any reason, earthquake or heavy rain, if landslide affects, so how many land has been displaced, what is the loss, if there is some kind of, if the landslide is very major, then if there is some village nearby, then so we can analyze the effect on the village. So that kind of mapping of land can be done. Uh, then mapping of land can be used for a mining. So if any region is specifically allocated for a mining, so we can monitor the mining process. We can monitor deforestation and desertation application. Uh, we can also create a constant map. We can create a constant map using uh, like for agriculture thing, we can monitor growth. We can constantly monitor the progress of uh, any kind of project. So we can create DEM, digital elevation model, in a very efficient manner. So the conventional method takes a few days to make an elevation model of anything, but using drone, you can just uh, make it within 12 hours. So 6 to 7 hours for data capturing and drone flying, and another 6 to 7 hours for processing, and it will create a whole point cloud, and you can create it. Infested crop damage assessment. This is the core use in the forest and agriculture side. Currently in India, agriculture is a little bit difficult to penetrate due to the mindset of people and financial flow inside the agriculture domain. So right now in India, farmers are not very much open to accept this kind of things because it is quite expensive for them. But in forest, right now, so many forests are using this constant monitoring for deforestation, and if they have developed some specific region as a forest, so they use these drones for this kind of service. And last month I was at Gujarat Forest Ranger College, and there we also do similar kind of thing where we teach them use of drones and how to determine different data from it. Uh, then 3D dimension terrain model construction. So if there is any kind of construction site, so every 15 day or 1 month, we can create a 3D model and monitor the progress and check the alignment and everything. So using this, we can create a 3D model easily, and we can check all the dimensions uh, from a remote location that if this construction is going as per our model or not. Volumetric analysis, uh, majorly used in the mines. So currently we have a few clients like Sangi Cement, who are into mining and cement manufacturing, and they use our service on a very frequent basis. So we visit their site every 15 days or 1 month, and we take a survey, and we just then give compared two results. So say for example, if we took first survey today, and next survey we will do on 15th October. So we will compare these two survey, and we will give them a result that how many of volume of land has been taken and what is the difference of volume, and then they will, based on those data, they will make the whole planning, and will they will check their data that what is the uh, quality. So of thing, uh, they will check their production data, see whatever is going on paper, is it matching or not. It is kind of a feedback thing. And if they want, we can also provide a soil analysis of for specific metal or mining or those kind of, where we go for a multi-factor survey, and we give them identification that these are the spots where things are possible. So instead of just sticking everywhere, we can make it things more efficient. Atmospheric science. So just in the beginning of this session, we discussed that Google and Facebook and so many other players are trying to use hot air balloons for this kind of things, and it will make uh, internet accessible, as well as lots of other weather data at different altitudes. And using those data, it will help us to predict weather in a very accurate manner. Agriculture. So agriculture is one of the those domains where you can use drones on a multiple layer. So uh, so what in the agriculture, what we are doing is we provide a two kind of services. One is the land quality and pesticide, land quality, and another application is pesticide. So using multi-spectral camera, so we provide a whole package to the farmer. We provide them a package of 4 months, 1 season, where we start with analysis of land, that how, what are the level of interest, and uh, where land is not up to the mark of their, as per their requirement. So we do that survey, then we instruct them, okay, these are the pockets where you need to put some additional fertilizer or those kind of things, or if you need to make some, add some minerals or those kind of things. Once they do it, we constantly monitor. Every 15 days we monitor the crop health. Based upon those crop growth and health, we also advise them uh, to provide uh, a pesticide in a specific region. So currently, what everyone and what we all are doing, that this spray pesticide on each and every level, but that is not necessary. So on those basis, we advise them, okay, this is the thing where you can use. You just need to spray pesticide. This all are okay crops, so they are healthy, so you don't need to use it. So by that means we are also reducing the use of pesticides in the agriculture. And then even for spraying pesticide, we can provide a drone service, and this thing is a constant process where we provide data. So these are the some of the limited applications which I have discussed. As you all people being in this field in the civil, you can explore more and more additional application for that, and for that you can even approach us, and we can even find that, okay, these are the application possible. And as uh, we are into drone research thing, we can work on some kind of new applications, can open the more domain. Now, if drones have so many benefits, then why everyone is not using it? Why it is not still as popular as it should be? If it solves every problem of us, then why not? So there are some certain obstacles for it. First is the physical limitations, like limited flight time, data storage, launch method, schedule serve applications to smaller missions. Uh, it also includes a cost factor too. Uh, so due to this thing, it is currently its application is limited to do a surveying of a specific limited region, and we are not doing on a large scale. Another thing is a safety. So as drones are a flying machine, so we know that this whole aviation thing is currently regulated by lots and lots of regulations, but there is not that more of those regulations for a drone industry, and even drone manufacturers are not very well prepared uh, to follow those heavy regulations. Uh, so not on the technology basis as a manufacturing, but on a price factor. So currently, what this market is whole going and what are the regulations of real aviation industry, we can't directly implement all things in this unmanned thing because aviation industry deals with manned services and these drones are unmanned system. So definitely every country, including India, is working on creating new rules for the drone. But till then, safety is going to concern. So say for example that some drone is flying at 500 feet and suddenly it uh, occurs some failure and it just land on someone's head. So that may be a issue. And third thing is a privacy and nuisance. So this privacy and nuisance thing is a constant headache for the whole industry. Usually every 3 to 6 months we observe some kind of misuse of drones, either they get penetrated into some kind of no flying zone like airport or some private spaces, or just a recent 4 months back, 3 to 4 months back, Jammu and Kashmir incident. So this all hurdles prevent us from using drones from on a very wide level. So, what are the types of remote sensing? So, we discussed a few applications of a drone uh, in the GIS, but what are the types? So, majorly, there are two types. There is a two method of doing remote sensing. First one is a passive remote sensing where we use sun's electromagnetic energy and its reflection to identify uh, details there and create image accordingly. And another method is active remote sensing where we generate our own energy source and gather data from it. So common example of passive remote sensing is IR or RGB camera system, and for active remote sensing we can use Lidar and radar. What are the methods of going for a survey? Uh, so we discuss application, we discuss drone, we discuss methods, but from which things we can do this remote sensing? Ground-based, airborne means ground-based means where you are at certain height and you are gathering data. That is a one way. Airborne means aircraft or any kind of those things. Space shuttle, satellite. You all are familiar with that. Balloons, lighter than air, drones or UAV, helicopters, and satellites. So currently, GIS more commonly used by satellites, uh, and the rising field is drones or UAV and balloons. So the most advantage of balloon is that as lighter than air thing don't require energy to stay in the air. Either they are based on helium gas or uh, or some kind of minor heat sources. So they consume comparatively very less energy to stay airborne. So with respect to fixed wing, multi-rotor and balloons, they require a very less energy. So we can take a benefit of maximum flight time in the case of balloons, but the problem is the velocity. So as they are lighter than air and they have certain amount of big size volume, so velocity is a limitation in the balloons, but flight time is advantage. In the case of drones, velocity is your advantage, but flight time is comparatively less. And in the terms of fixed wing, you can get a flight time, but you can't hover it on a one position. You can get a maximum amount of velocity, but not a hovering. So based upon our application, we need to trade off with this thing. Now, what are the types of sensors used for remote sensing? And then we will also discuss about types of sensors used in drones. So, as the applications, active and passive remote sensing is done the same way. We have a two type of sensor, active sensor and passive sensor, and based upon electromagnetic wavelength. So active sensors include RGB camera or IR. Passive sensor includes the lidar and those kind of things. And another classification we can go for is based upon your wavelength. So first is the OIR, optical and infrared region, microwave region, non-imaging region, and imaging region. And these are the sensors used for GIS in drone. So first one is a multispectral camera. So multispectral camera consists of different lenses in a single image. So multispectral camera consists multiple lenses in a single device. Current right now the easy level of multispectral camera have a red edge, near infrared, green, violet, red. So red on the lower region and red on a higher region, and blue. So red edge, red, violet, blue, and green. Five colors specifically they can capture on an individual basis and NIR. So the system records these six images on a simultaneous basis. It clicks photo simultaneously and records everything simultaneously, which helps us to determine uh, data on a more specific way. Another thing is a thermal or NIR. So basically, thermal camera is specifically for infrared thing, and NIR means near infrared region. So definitely in thermal you get more data for it, and NIR is a kind of you can say cost-effective solution for some of the applications. So where uh, we will also discuss one of the core application of this thermal camera in the next slide, in the civil construction. And third one is a lidar sensor. Now, why this lidar sensor is used? So lidar is a very similar operates on a very similar concept to a sonar thing, light detection and ranging. Uh, why this is used is because currently whatever is happening, whatever 3D modeling and what we are creating is usually a result of photogrammetry. But in every case, photogrammetry is not accurate solution. If you need a very precise location, or if you are at some of those regions where you can distinguish two different points. Say for example, desert. So if you take a aerial photo of a desert, it's very difficult to identify two different points for a software algorithm. In those cases, to create a digital elevation model using RGB camera or normal photo is little bit difficult. But if you use this sensor, so with respect to drone location, you can get a point, surface point specifically, and then you can just process it and create a 3D model. And most commonly used is RGB camera is always there, a normal which we use. Either you can call it a GoPro camera or anything. Those all zoom camera, all are already available in the drones, and you can anytime use those things. So this is the one of the thermal image of one metal pillar. It is actually very close, very zoom image. So here, what this whole spot you are seeing. So I talked that IR camera. So actually, this metal pillar had a minor crack inside it. Uh, using this thermal camera, you can always identify, you always and easily identify this crack, because whenever there is some kind of minor structure failure, heat get concentrated there, and it always shows some kind of heat difference. So this is the one of the example of crack identification using thermal camera. So many time, in the foreign countries, not we have done it now, but many metal bridges and those structures are constantly surveyed and monitored using drones and IR camera to identify a certain structural failure or a weak point. Not a precise failure, but we can call it a weak point in big metal structures to prevent a failure. So prevention is always better than a cure. So they are so these are the things used for survey. Now we talked about almost everything: remote sensing, drones, and everything. Now we will talk about output of drone and uh, of their services. Okay, how it is done and what are the end results of it. So before that, what is an image? So this whole remote sensing thing works on an image. Right now, we all are almost very much familiar with image. We all click a lot of photographs which represent a different layout of color and which helps us to identify certain objects. But image is actually, you can call it a matrix, and where each pixel contains a certain data which represents something. So an image is a pictorial representation of an object or a scene. If the image is analog, it's on a paper-based transparent media. So which we were using in the roll camera. But right now, it's completely out of it, and we are not into analog. Right now, everyone is using a digital image only. So digital image composed of is a complex a matrix. So whenever we say a 1080p resolution, so 1080p resolution indicates a 1920 pixels on horizontal side and 1080 pixels on vertical side. So the total number of pixels available in that image is a 1920 cross 1080 pixels, and that number of data is available with you. So for us, what we normally use, so that all pixels, that all matrix contains a specific RGB data, but you can, if you go into advanced thing, that same image may contain NIR data or some kind of numerical data which may indicate a location of that point if it is a 3D model. Even this 3D model, whatever we call, are actually a stacking of images kind of thing. It is a three-dimensional matrix. So whatever image we see is a two-dimensional matrix, but if we go for a 3D model, it is actually a three-dimensional matrix. So based upon this, it also helps us to create a, a model or whatever data we are looking for. Now, this is the one of the concept is overlapping. specifically for remote survey. So whenever we capture data, either it is using satellite or drone or anything, for an image we follow overlapping system. So in this first thing, you can see a 60% overlapping. So overlapping is nothing but a common area between two images. So when you click two images, how many percentage of area you have kept it common, so that it can stitch it properly, and it helps you to identify and create a 3D model. So in the first case, you can see that the center square is covered by actually total 4 images. So for a good, if you go for a 60% or 80% overlapping, we usually prefer 80% overlapping on a front and 60% on a side left. So front means, so if your drone is going in a forward motion, so the distance between two click photo is called a front overlap, and side overlap means it rotates in a zigzag pattern. So the distance between two zigzag pattern is called a side lap. That I will show you in the software while designing map for a surveying. So this overlapping helps us to get at least minimum 4 photo of any point, and such that it helps us to identify exact location and altitude of that point. Now, why we need at least 4 images? So whenever we create a 3D model from 2D images, we use a stereoscopic vision concept. So basically, we all have a two eyes, which has a distance between around 6 to 7 centimeter from each other, and that distance help us to identify a depth for that object. So using this distance of 6 centimeters, we can precisely identify that how far that specific object is. Now, in this case, you just take a look that for a specific area, you are capturing thousands of photos, and using that combination, you are creating a 3D map. So that's why you require more overlapping, such that it helps you to create a depth, and that helps you to create a more detailed elevation model. This part we will cover on a later stage. Oh, yeah. So software used for drone survey. So these are the currently most common used survey software are listed here: Pix4D, Bentley, Context Capture, Global Mapper, and Edges of Metashare. First four softwares are offline software, where the whole software get installed into your system, and then you need to process everything on your system on. And fifth one is a drone deploy. So drone deploy is so this all softwares are licensed, and even for a drone deploy, it is an online thing where you need to upload things online, and they process on their own server. But it is also a paid thing. But you can definitely get a 14 days trial for those things. Okay, so let me show a drone deploy software to you. So majorly we use Pix4D software for our project, but sometimes if needed, we also use drone deploy. Yeah. So currently I have opened our trial account with you. Okay. So drone deploy, you can use drone deploy from either a desktop app or a mobile application. So this provide all-in-one solution where you can even fly a drone and it helps you to get everything processed. So this is the GFRC college, Vadia Palace at Rajpitla, where I was last month. I was there, so I have the sample data available for that. So I'm showing it to you, and I don't need to follow any kind of commercial purpose for it. Otherwise, other data are commercially not possible to use. That's why I'm showing you a thing which we are permitted to show. So this thing is simply a map model. So this helps us to plan a flight, flight as per our requirement. So whatever this patch you are seeing is a map created by us, and under other regions are a ready-made map available from Google. So here itself, you can see a difference between a drone image and a satellite image. So uh, okay. So for now, I have set a flight height at a 200 feet. But if I need a more detailed resolution, I can reduce it to 100 feet because it is a forest region. So average tree height is always below 80 feet. So we can use that. But here you can see that as soon as I change the altitude from 100 feet, my flight minute requirement changed to 36 minutes. Previously, for a 200 feet, it was 13 minutes, and when I moved down to 100 feet, it changed to 36 minutes. And my resolution is zero point 0.4 inch per pixel. Now, in the case of satellite imagery that stays around 1 meter or below, you can go for a half meter and those. But it has a certain limitation. But definitely using satellite image, you can get a resolution of zero point 0.4 inch per pixel. So this helps you to create a lot more preferred data. So let's keep a 100 only. Now here what you are saying is the enhanced 3D. So right now I switch the enhanced 3D model. I don't want to create a 3D model. I just want to create a map. So how my drone will fly? Uh, you can see my cursor. Yeah. So this is the start point of a drone. So it will travel on this manner on a zigzag line. But it won't. So it will travel on a vertical side only. It won't fly on a horizontal side. So it will just start from here. It will travel on this path, and once it reaches here, it will come back to a landing. But if I enable enhance 3D, so it will cover everything horizontally plus vertically and plus perimeter 3D. So it will also capture images from a side and top horizontally and vertically. So it will help a drone to get more data of each point. So once you get this thing, you get 6 to 7 images of each point. Okay, so this is the front overlap and side overlap setting. So front overlap means the drone is flying in a straight direction and a distance between two number of images is called a overlap, and side overlap is a distance between percentage of overlap between two side images, means between these two lines. Now if I change a front overlap, say for example I am reducing it to 60%, so it will just change my flight time. You won't see any kind of change in a flight path. It will just reduce my time. If I change it to 80%, it will increase my flight time, because at every click it reduces speed at some certain level, and that helps that increases the flight time. But if I change a side overlap, say for example I am reducing to 60%, so here you can see a change in this whole metric. If I increase it to 90%, so it made a grid more congested, and here you can see that your flight time increased to 109%. We usually use 60% side overlap and 80% front overlap. But if required, if we need a more proper 3D map, then we even change and increase it to 90 in certain cases. Then flight direction. So why this flight direction is important? It helps to capture a more data. Say for example, if I'm changing this degree to 180, no change. So you need to change the oblique. So this way, so this thing depends upon your map. So here, this palace is as per our 90-degree thing, vertical and horizontal aligned. But there may be a certain places which may be at certain angles. So to make efficient map of it, you need some angle of light, keeping it 90 only. Then mapping flight speed. So this shows the speed of a drone. If your drone flies at a very high speed, it may create a shaky image. Uh, but usually optimum speed which we use for our drones are 5 to 12 miles per hour for a general thing. So we usually use either DJI Mavic Pro or DJI Inspire, and one our custom built drone. So for that we keep it usually 6 to 12 or between 5 to 15 based upon our requirement. Then starting waypoint. So starting waypoint is a feature which is used for uh, 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 as and the thing which we mentioned, that the limitation is the flight time. So our drone can, a normal drone can fly for 30 minutes only, and here our requirement is a 34 minutes. So for a safety, we usually take a flight of 20 to 25 minutes only. So in that case, we can set a starting waypoint. So say for example, during 20 minutes of flight, it is already covered 41 waypoints, and now this only perimeter things are pending. So it can start from that point direct. And this one is the perimeter 3D. Let it to work so that it's clear. So if we switch off this perimeter 3D, the drone won't fly on this perimeter. It will just fly on this cross hairs only. But if you go for a perimeter, it will take a oblique photograph from all directions, which just give us the enhanced 3D result. And crouch has 3D, which I mentioned for a better 3D view. So these are the thing by how we plan a flight. So it is just as simple that the area you want to set, you just select it and then just set few certain parameters. Here we didn't take a concern of a camera focal length and everything, because here I have already defined our drone Mavic 2 Pro camera. But if I have some custom camera, then I can define the focal length and megapixels and other factors of it, uh, so that it can uh, um, make a flight plan accordingly. Now, what are the parameters which we need to consider for a planning of flight? So, focal length of camera. So, focal length basically indicates how much area a camera will cover in a single image. So, the larger the focal length, the more wide angle you get, the more area you cover. So, that focal length of camera helps you to determine the overlapping. Second thing is the flight height. Flying height helps you to determine your resolution, means the thing which we show 0.5 inch per uh, pixel. So that thing it helps to determine, and again a flight path where you consider a overlapping. So flight height helps to determine that. Size of area. Size of area means the area you want to create a survey mapping. So that size of area will help you to create a flight path and a flight timing for it. Size of photograph. So how much resolution each photograph will cover and how many area will it cover. End overlap and side overlap. So that helps you to again determine a flight path for a better result. Then scale of a flight map. So thing which you mentioned a 0.5 inch per pixel. So this becomes your scale of a flight map. And ground speed of aircraft. Uh, this determines a flight time and at for how many time you need to make it fly to get it done. And if you want to reduce the flight speed, so uh, how exactly it will behave while capturing its images. So here, if you are going for a multi-rotor, so if the area is a comparatively smaller, then you can go for a multi-rotor. But if your survey area is long, say for example, railway survey. So for a railway survey, we usually use fixed wing or flying wing kind of design, where the single aircraft can fly for a longer duration to up to 30, 40, 50 kilometers. Hmm. So this is the thing which I show, that how to gather a data and what are the factors you need to consider while gathering data. Now, once you have all the images, I will show you images too, that what are the captured images. So it will help to understand. So I will also show you image so that So it will help you to understand exactly oblique photograph and overlapping. Okay. I guess screen is visible. Photos are clear, only visible to you. So this all starting images are on a top view, and as our prime focus was to create a 3D model of images, so we kept cameras at certain 30-degree angle so that we can get as much as side photos of the palace, and that will help us to create a more detailed 3D drawing of. So this all are photos while drones fly on a cross hatch basis. And these photos which you are seeing, uh, that is the output of a perimeter vision, where we kept a camera angle at around 65 degree. It was a complete oblique photograph, and it took a photo from all 360 angles, from all different angles. You can see the drone is revolving around 360 and clicked lots of photographs. So this is the RGB data we captured from our drone, and that is just one image. So this is the way drone captured image. You can see detailing of photo, and as it captures a complete 360 photo, so it will gather all data and will generate a 3D map from this data. So these all photos we uploaded to this thing, and then we got the output. So here, as a service provider or as a working person, our effort was, I will first get creative. So this is the detailing of orthomosaic map created using more than 250 images. So here for this palace, you can see that there is no relief displacement error for it. Still, this thing we actually captured at a 200 and 150 meter of height because it was just a training program and detailing was not our prime focus to showing them the whole process and working on different things. That was our prime focus. That's why we captured for such a very height. Still, it is this clear. If we wanted a more detailing, then we could have changed certain parameters. And even in this thing, we use only 60% of overlap. We haven't run for 80% overlap. Still, it showed us very satisfactory result. Now, how can I use this? So once this map is generated, if I want to find anything, let's say area of a terrace. So how this thing makes a process easier? If you like area tool, now the once my 22-minute flight time is complete, and then if I get it and I process it in 2 to 3 hours, then I'm good to go for gather any data available here. So it just process this whole area and it shows that this total area is a 0.55 acre and surface area is 1 acre as it already has a 3D model. From that it is simply identified a total surface area available for that. So this can be used to determine area. Plus, say for example, if you are going for a paint job of some kind of bridge or anything, so if you have a 3D model, you can simply go get a surface area very easy. Same way, if I want a distance between 2 points, say for example, now I want to measure uh, diameter of this circle. So the length of this circle, diameter of this circle is a 140 feet. It's just as simple as that. Just you just need to click and you will get a thing. Now here you can see one more point. It also shows elevation difference among that line. Say for example, I want to measure a height of this stone. So here you can see, okay. So with reference to datum line, the elevation of ground point is minus 52 feet, and then I'm taking a point to this. So let's say for simplify, I'm calling it 40 feet, and this is minus 52. So the height of the top of this dome is 40 plus minus 52. So minus 52 plus 40. The difference is 92 feet. So here I can easily determine the height and its detail of a thing. This is the one way where we can identify. Another way we can go for a 3D thing too. Now for the certain processes, you can anytime automate the process and you can set few commands. But right now in this drone deploy, it is not possible. Drone deploy is a very simplified version of this whole process. So they have certain fixed parameters for that. But if we use Pix4D or other softwares where we can go for a customized thing, then definitely we can do lots of things. Oh. Another thing which we can do using this is create a elevation model. So using this map, we can easily determine a height between certain things, and we can always set our color coding according. So say for example, I am just okay. So here I have determined that below minus 32 feet from a terrace height. So it has a considered that as a datum line. So from terrace height, whatever is the below that, it will be shown as a blue minus 32 from a ground floor, and above one, whatever is above terrace, it will show as a red. So by that means we have created a complete elevation model. Here we can exactly say a elevation model, but because it contains a tree, but by this manner you can always identify uh, certain things in the map. For the proper elevation, let me show you one of the ready-made example of a okay. I guess there is some internet issue. Hmm. Okay. Hmm. So basically, I wanted to try show you a elevation model for agricultural land, and using the specific color domain, you can easily see the flow of the slope of the land, uh, and you can easily determine the uh, zones where water can be logged. So even during construction site, this is a very essential thing that what is going under construction. Uh, you determine the slope of that land, and it will help you to determine the data. If you go for a this whole process for a manually, it is a very tedious job and a long process. Hmm. So to similarly we identified a height of a dome, so and area of that the whole terrace. Similarly, just by using this simple process, using selecting the area, we can determine the volume of those process. Uh, Somehow, due to technical issue, I'm not able to load my map. Let me see if already if I have a screenshot of it. Hmm. So once your whole data is processed from images, uh, it creates a complete point cloud. Map. So, this is the report of annotations created for this thing. So where the first is we determine a height of the 2 points. So what is the distance between those two things? Area, volume, and count. Uh, it's not covered in the map. So actually, we run a count program for a specific palm trees behind this whole map. I guess that thing we can see from. Okay. So here, there were some 5 to 6 palm trees. So we run our program for that, and that you can see from the map. I'm not sure what's the technical issue. Uh, no issue with that. So we put our program that if you find this specific step which is similar to palm tree, then it should consider it as a palm tree and give us a counting. So after running those algorithms, it gave us the output of total 16 count. In actual, it was actually 14, but as this is a comparatively lower resolution data from a drone, so it created some error and it gave out of it count 2 more trees as thing. And we also tried to run a program to count a number of rounds, which indicate the number of tiles. But it took much more than our expectations. So currently, I'm not able to get the output on our system for that. This is the elevation model, which we accurately determined that the stereosite is a datum line, and everything bluer shade is below it, and everything redder shade is above it. So by this means we can create a complete elevation model. If you ignore it that these are the trees, so you can assume it is a elevation model of some kind of hilly area. And this whole blue thing we can consider it as a waterlogged body, where if anything, if rain happens, water will get flow into that direction. Uh, this we designed for okay, it is the same elevation model only, but we changed requirements for it, and we just said it if certain things is above 80 feet, then you just need to highlight that section. So it shows the region, this region. It is the same elevation model only. And this is the orthomosaic map result output created by a software. This was a little bit modified by us. So what I show you on the direct website, it had some kind of specific linear marks, but here you won't be able to see the separate marks on it. This survey was done using a RGB camera, but if we had a NIR and multispectral camera, uh, then even we could have identified a plant health thing. So for a plant health thing, we usually use either color based. So from color item, we can even run a program that this specific shade of green should be counted as a healthy, and this yellow shade should be counted as a unhealthy. So even that we can see from a certain region. So this all things can be done in just 6 to 9 hours if we want to use things efficiently. So this was it from my end, from my presentation. Wanted to show you something more on live demo side, but I guess due to some technical issue, I'm not able to load my map right now. But majorly everything is covered. I just wanted to show you a volume factor, that how exactly volume things work and how can we utilize it. But it's okay. I have already shown enough things. So do any of you have any questions? And meanwhile, in this process, I'm still trying to load the map if I get to. Anyone have questions?
Okay, so participants, if you have any kind of question, then you can unmute yourself and ask the question.
And right now, this 3D map is loaded. So this complete map is uh, constructed using uh, photographs only. Right now, it's still loading. Once it gets clear, you will able to see more detailing. So here you can see that from this thing, even if it was kind of in the covered section, but still these images are able to determine even this minor slope of the stairs and walls and everything. Definitely there is some kind of glitches in the trees, but with what level of data we captured and within the output we received in 24 minutes of flight time, it's comparatively quite good and more detailed than as per our expectation.
Uh,
Hello?
if
Yeah.
I want to know in systems that will measure the details continuously, then is it possible that we go for drone, or we should go for these the airborne which you have said in the initial thing?
Sorry, your voice was a bit cracking. Can you please repeat the question?
Hello, I am asking that if I want to say a construction site is going on, and I want to capture the data continuously,
Hmm.
then, and you know that at the height it is not possible to that I should install something or that. So whether at that position it will be better to go with the drone, or better to go with these that helium balloon type of technology.
Okay, as you want to inspect a specific construction site, so definitely helium balloon are a more preferred solution. We also want a detailing. So helium balloon, you can't keep it at such a lower height. So there is a midway solution for it, which is we call a tethered drone, where you provide a power supply to a drone from a ground. So we put usually a generator or those kind of thing on a ground, and then we uh, uh, make a tethered drone to power it from a ground. So which can technically on paper it can provide us an infinite flight time, as we are giving a power source from a ground. And once but every 12 hours we need to get it down, because to maintain the quality of the device.
Why I'm trying to just understand this thing, that if at any site, see that if the verticality is to be maintained, if the level is to be properly done, if the elevation is to be properly maintained. Now these things many a times that uh, we know that there are sensors available or GPS is available, but from certain position, if I want to get the data, then it is difficult. So in those conditions, if the application is possible, then I think it would be helpful to the site people also.
Yeah, so in this case, we don't need to keep one drone constantly on the air. We can even go for a daily basis survey, where if they go for a specific leveling, then we can go for a daily basis or as per requirement survey.
Mhm.
So that will be
Okay.
a more preferred solution and more cost-effective solution for this application.
Okay. And can you just tell me what will be the cost around for this kind of practices?
It completely depends upon your area requirement and how many things which we need to invest. So there is not nothing as such a fixed costing for it. We need to discuss it.
Okay. Thank you, sir.
Okay, so I think